binomial problem. But in this case, it's as if the coin that we flip is unfair, right? So a 96% chance that we get heads, a 4% chance that we get tails, something like that. And so in this case, we want to know if 4 items are chosen at random, what's the probability that at least one will have a defect? Well, another way we could put this, I mean, the probability that at least one will have a defect is just the opposite of the probability that none of them will be defective. Because if at least one is defective, then there's 1, 2, 3, or 4 defective. And so the opposite probability of that would be that there are none. So the probability of at least one being defective, which is what we're trying to find, we can find that just as, or even easier, by taking 1 minus the probability that 0 are defective. So what is the probability that 0 are defective? Well, you have 4 items, each at a 96% success rate, and we want to find that what happens, or the probability that all 4 of them are successful. So that is 0.96 to the power of 4, right? And so for the actual binomial distribution, this equation would be 4 choose 4 for how many are successful times 0.96 to the 4. That's how many are successful, that percentage, times 0.04 to the 0. But this ends up being 1. This ends up being 1. So we're just left with 0.96 to the 4th, which is about 0.849. So our final answer is 1 minus 0.849, which leaves us with about 0.151. Yeah, 0.151. So that's our final answer there. The probability that at least one will have a defect is 0.151. And if you think about it for a sec, that should make sense. There's a pretty low rate of defect, only 4%. And so the chance that any one of them or more will have a defect is going to be pretty low until you get a larger sample of randomly chosen items. So there you go.